In this question, we have been given that the diagram shows a small bead of mass m carrying charge q. The bead can freely move on a smooth fixed ring placed on a smooth horizontal plane. In the same plane, a charge plus q has also shown. So that is here. The potential at point A due to plus q is V, and with which the bead should projected from point A, okay, so that it can complete circle and should be greater than, okay. So here if we look this problem, so first of all we will try to use the information that is given in this problem. So I will draw a circle here first. So this is our circle, and this is basically the diameter of the circle. So this is the diameter of the circle here, and there is a charge here, that is plus q, which is at a distance a from this side, and this side this distance is 4a. Because of this charge, potential here is v, so I can say that potential at this point will be how much? 4v. Okay, now it is saying that what should be the minimum speed that should be provided to it so that it is able to complete the circle. Okay, so let's say we have given some speed u to this one. Now we need to understand that where the position which one is the critical position after that particle can do the circular motion by its own. So we have to investigate this. So let us take a random position over here, okay, at this point, and this is the center I am saying. Okay, so due to charge plus q over here, you will find that a charge q, that is the charge which is at this location, okay, when this charge position is here, this instant it experiences a force in this direction, that is a force. And if I draw a line from the center, okay, then the line from the center, if I draw, this is like this way. So you can clearly see that this force will have two components. Okay, this force will have two components. One component that is along this line, which will not affect the speed, and other component which is tangential to it, which will try to retard it. Okay, so basically when the particle is moving on this track, this component is trying to decrease the speed, okay, try to slow it down, and this component is not doing any kind of work to increase or decrease the speed along the tangential direction. And this is not happening only at this position, it happens throughout the position from here to here. If I just show you another position, let's say at this point, if I consider this position here, now you will focus at this position. From this point, the force, if I show, the force is like this way, and then in that case if I draw a line from the center, okay, so that is along the radius like this way, then you can see that the force that is acting on it, this force again has two components. One that is along the radial line, which will not affect or which will have zero effect on the speed part, and this component which will try to retard its speed. That means I can say that when the particle is from here to here, this force, the component of force, one component of force which is opposite to its velocity direction, always try to retard it. That means if a particle is able to, anyhow it is able to reach from here to this position, because when the particle reaches here, at this position if you see the forces on it, the force is along this line, so this force has no component along the tangential direction. Okay, and after that if I consider any point over here, let's say that when the particle has reached to this position, so for this position you will find, let us consider this position here. For this position, what you are going to find, you will find that the force is acting like this way, and from the center if I join the line to that point, then you can see the component of the force. Okay, the component of this force, basically there are two components of the forces, one along the radial line, one perpendicular to the radial line. So this is along the radial line and this is perpendicular to the radial line. So you can clearly see that this component is trying to, this component that is here, this component is trying to increase the speed, whereas this component has no role. That means when the particle is from here to here, this particle is continuously experiencing a retarding force which is trying to decelerate it, and once the particle reaches to this position, and even if the speed is slightly greater than 0, then it will be uh, repelled from this position to this position, so it can simply complete the circle once it crosses this position. So I will use conservation of energy between this point and this point. So let's name this point, and after naming it we can solve it. So let's name this point as A and this point as B. So I will be writing EA should be equals to EB. I will say total energy is conserved because only electrostatic force is involved here. What is EA? EA will be kinetic energy at A plus potential energy at A, and EB will be kinetic energy at B plus potential energy at B. Now kinetic energy at A is how much? That is half m, and this is, I have said it is U square, so let us consider U square. Potential energy is Q times V here, and kinetic energy at B I am saying let's say half m V square, okay, and here I am assuming speed to be V at B point, okay. Let me show it to you. Here I am assuming speed to be V, and potential energy V dash, because V already we have used for the potential notation, so we will say V dash, plus potential energy at B will be 4 QV, because potential here distance is 1 by 4 times then this distance. The distance of particle from here to is 4a, and for 4a potential is V, so for a distance potential will be 4V. Now if you simplify it, you will get half m U square, that is nothing but 3 QV plus half m V dash square. Now for U to be minimum, okay, for U to be minimum, I will say that V dash should be equals to 0, means the particle should reach here with speed slightly greater than 0, then after that it will be automatically repelled to this position. So here I will see that if you solve it, you will find that U square should be equals to 6 QV by m. So U should be equals to root of 6 QV by m. So that's the minimum speed that we got here. So minimum speed will be how much? Root of 6 QV by m. So the correct option is option A here.